Hi, Algebra 1 students. This is a video for lesson 9-1, the second day. So the first day we did jailbreak or simplifying radicals, and we're continuing that, but today we are looking at quotients. So what I want you to make sure you're doing as you watch this video is pause the video if you need to take notes in your student journal on page 279. So quotients are division problems, and for our purposes, our problems are going to have fractions in them. Fractions mean divide. So this kind of explains what we're doing here. If we have a fraction under the radical, we're going to give each the numerator and denominator their own radical or their own jail if we're using the jailbreak method. And then we're going to perform our jailbreak or simplify it because this trees down into 2 times 2, and the square root of 4 is 2. The other thing that we're going to look at in this section is something we put in our vocab on page 278. We put in our vocab what rationalizing the denominator means. It means removing a radical from the denominator. So today we're looking at fractions, and when we have a rational or a square root in the bottom or in the denominator of our fraction, that is a no-no. So we're going to learn how to get rid of that rational in the denominator. Okay, so the first thing I would like you to do is to write these two example problems in the note section on page 279. So pause the video and write those in. And then we're going to go through those. Those are your first two examples. So first thing I always want to start with doing is seeing if I can do a jailbreak. So if I'm just going to do this over on the side, if I do a tree on 15, you'll notice 15 has a tree of just 5 times 3. Those are both prime numbers. So I can't do a jailbreak here because there are no partners. There's no doubles. So once I check that, then what I want to do now is rationalize the denominator. So I cannot have a square root in the bottom of a fraction. The way that I get rid of that square root in the bottom of the fraction is actually not too difficult. If I'm trying to get rid of the square root of 15, I'm going to write a new fraction that has the square root of 15 over the square root of 15. And I'm going to multiply that new fraction by the problem I originally started with. So whatever radical you're trying to get rid of, create a fraction where you have that on the top and bottom and multiply by it. So I'm trying to get rid of the square root of 15. I'm going to multiply the top and bottom by the square root of 15. Okay, now remember, if you start with a fraction, you're going to end with a fraction. So keep your fraction going. Now I'm going to do this multiplication. So on the top, if I have 3 times the square root of 15, that's just 3 outside the jail. Don't put the 3 in jail. It's not in jail. Times the square root of 15. 15 is in jail. Keep it in jail. It's like multiplying 3 times x. It's just 3x. Or 3 times the square root of 15 is just 3 times the square root of 15. Now these 15s are both in jail. So we're going to keep them in jail, but we're going to put them in jail together. And remember, pause the video if you need to take notes. Well, you do need to take notes. If I'm going too fast, pause the video and then update your notes. Now, if you notice down here, these are doubles. They can break out of jail. So I can do a jailbreak here. 15 and 15 are partners. They escape. Only one makes it out alive. So keep going with this. Still a fraction. In my numerator, I have 3 times the square root of 15. What I have on the bottom is 15 outside the jail. I circled everyone in the jail, so the jail is empty, so I don't need a jail anymore. Now look what happened. I started with a square root in the denominator. When I'm done, I have no square root in the denominator. So multiplying by that identical square root is what gets rid of the square root in the denominator. Now there's one more step here. This 15 is in jail. I cannot do math on him, I like to say. Cover up that 15 and check the numbers outside the radical or outside the jail. If that's a fraction that can be simplified, you need to simplify that. So 3 over 15 is the same as 1 over 5. 3 divided by 3 is 1. 15 divided by 3 is 5. So what I have is 1 times the square root of 15 over 15. Oh, no, over 5. Sorry about that, guys. 15 divided by 3 is 5. Now this is fully simplified. So what I started with and what I have, those are equivalent. This is just in the simplified form. The directions for these problems will say simplify. Notice when I simplified 3 over 15, I didn't divide the 15 into this 15. This 15 is in jail. You cannot touch it. You can't do math on it. Okay, let's try another one. Step 1 is always do a jailbreak wherever you can. Now, if I think of 5 only has 2 factors, 1 and 5, and I have no doubles. So this cannot be simplified, okay? So I'm just going to say I'm still going to have the square root of 5 in the numerator. Now 20, that can be simplified. I'm going to do it over here so I don't run out of space. So 20 is 2 divided by 10 and 2 divided by 5. Those are all prime numbers, so that's the bottom of my tree. So 20 is the same as 2 times 2 times 5. Bottom, bottom, bottom. 2, here's my doubles. They break out of jail. Only 1 makes it out alive. 2 is outside of jail. 5 is stuck inside of jail. So the square root of 20 in simplified form is 2 times the square root of 5. Okay, now take a look at this. The square root of 5 over the square root of 5. Well, first of all, let me say, right now I cannot be done because I have a square root on the bottom. But instead of doing this, where I multiply, notice the square root of 5 divided by the square root of 5, anything divided by itself is 1. So I get square root of 5 divided by square root of 5 is 1. I get 1 over 2. So this and this are equivalent. This is just in the simplified form. Okay, slide your paper down. We are now going to look at 5 and 6. So we have a fraction under a big square root. Give both of those numbers their own jail. So write it as square root of 25 over square root of 64. Now remember, yesterday we talked about our perfect squares. Those are both perfect squares. But if you don't recognize that, just do your regular jailbreak method. I want to see what can what can jailbreak here. So if I have the square root of 25, I'm going to do my work off to the side here. And I do a tree. 25 is 5 times 5. So I do have partners in the jail. Remember, you need 2 to escape. Only 1 makes it out alive. So this 5 is outside the jail. The jail is empty because I circled everyone in the jail. So square root of 25 equals 5. So if I'm continuing to simplify this fraction, I'm going to say equals, keep your fraction going. Square root of 25 is 5. So on the top I have 5. Now do a tree on 64. So square root of 64. 64 is 2 times 32. Divide by 2 again. 2 and 16. Divide by 2 again. 2 and 8. I'm going to keep going here. 8 is 2 times 4. 4 is 2 times 2. Okay, so I have 1, 2, 3, 4, 5, 6 2's. So 64 is the same as 2 times 2. Oops, sorry about that. 6 2's. 1, 2, 3, 4, 5, 6. Okay, now do your jailbreak. There's a group of 2. 1 makes it out alive. There's another group of 2, 1 makes it out alive. There's another group of 2, 1 makes it out alive. Everybody in the jail is circled, so the jail is empty. Outside jail, I have 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that equals 8. So this was a really long tree, but square root of 64 is 8. So up here in my denominator where I had square root of 64 simplifies to 8. So this simplifies to 5 over 8. Now, if you have those perfect squares memorized, we talked about this yesterday. So 4, 9, 25, 36, 49, 64, 81, 100. You can see where this would be a lot easier because you would recognize, oh, 25, that's the same as 5 times 5. 64, that's the same as 8 times 8. So then I could skip this big long tree if I had that memorized. All right, number 6. I have this negative out front, so that's going to be there all the way through. So my final answer will be negative. But let's start by giving the numerator and the denominator their own jail. Okay. Now, whenever I have a radical, I need to simplify it. So I'm going to do square root of 6 over here. I'm going to put a line here. Maybe you should do that too. So square root of 6, well, 6 is just 2 times 3. That's the bottom of my tree, and I have no doubles. So I know that the top of my fraction is going to stay the square root of 6. Now let's do 49. I hope that some of you, an alarm is going off in your head, and you're saying, hey, 49 is 7 times 7. That is a perfect square. So the square root of 49 equals 7. Winner, winner, chicken dinner. If that alarm didn't go off in your head, then you should start the normal process, which is make a tree on 49. Now, the one thing you might notice when you start checking to see what divides into 49, 49 divided by 2. I get a fraction. 49 divided by 3. I get a fraction. 49 divided by 4. Nope. 49 divided by 5. Nope. Guess what? The first number that divides into 49 evenly is 7. So even if you started the tree, you would quickly get to 7 times 7. So 7 and 7 in jail together. 1 7 is going to break out. Square root of 49 is 7. So this is simplified. I don't have a square root in the denominator. I have one in the numerator, but that's okay. The rule says no square roots in the denominator, in the bottom of the fraction, which I don't. So that is okay where I have that one. Now, what I would like you to do is turn to page 280, and I would like you to try this one. Now, I'm going to warn you, these are 2 rather big trees. So we're not going to do these problems. So if you want to do your work over here and then simplify that is what I recommend. Draw a line here though, because we are going to do this problem in a second. Okay, so you should have paused the video and tried this problem. And what you should have gotten is the square root of 2 over 5. So I'm going to show you with a little magic here, my work very quickly. Here is my tree. So first I gave them their own jails. Here's my tree for 8. And I got down to 2, 2, and 2. So here is square root of 8 rewritten as 2 times 2 times 2. Here is my tree for 100. So square root of 100 is 2 times 2 times 5 times 5. And then I did a jailbreak here. 1, 2, got out. this 2 was stuck inside. Here, 1, 2 got out and a 5 got out. Everybody in the jail was circled, so jail is empty. So outside the jail, I have 2 times 5. So in the top, I have 2 times the square root of 2. In the bottom, I have 10. Cover up the jail. 2 over 10 is the same as 1 over 5. Okay. Now we're going to have you cross off number 13 and write this problem in there. Square root of 5 over square root of 12. Okay, let's start by making a tree on 5. Hopefully by now you realize the tree on 5 is pretty small tree. 1 and 5, no doubles there. Okay, so I know my numerator is just going to stay as the square root of 5. Actually, I'm going to move this over a little because I'm anticipating we're going to need a little more room. Okay, now let's do a tree on 12. 12 is 2 times 6. 6 is 2 times 3. So square root of 12, I'm going to put it right in here. I can write it as 2 times 2 times 3. 2 times 2 times 3. Okay, now keep going here with your fraction. Top of the fraction, I have square root of 5. The bottom, do your jailbreak. There's some doubles. 2 busts out of jail. 3 is stuck in jail. Okay, now you might think we're done, but remember, we cannot have a square root in the denominator. So we need to rationalize the denominator. So I'm going to rewrite this here so I have a little more room to show my work for rationalizing the denominator. If we need to, we can work down here. We're not going to do this problem. So remember, to rationalize the denominator, I want to multiply top and bottom by the square root I'm trying to get rid of. The square root I'm trying to get rid of is the square root of 3. So multiply top and bottom by the square root of 3. I'm actually going to rewrite this down here because we need more room. You should do the same. So square root of 3 over square root of 3. By the way, this is equal to 1. When you divide two identical things, this is equal to 1. So this is just the same as multiplying by 1. So I'm not really changing my original problem. But what it does for me is it gets rid of that square root in the bottom of my fraction. So now upstairs I have 5 in jail times 3 in jail. They're both in jail. Keep them in jail and multiply 5 times 3. So I get square root of 15. On the bottom, I have 2 outside of jail. Do not put that 2 in jail. But these 3's are both in jail. I could multiply them together and write 9, but I'm just going to keep them written separate like this, and then I can very clearly see that I have partners in jail. 1, 3 is going to escape. So now I have still that square root of 15 in the numerator. In the denominator, I have 2 outside the jail, still sitting there. Remember, that's our getaway car. They stay sitting out there. And now 3 has escaped, so 3 is outside the jail. The jail is no longer needed because it's empty. Everything in the jail escaped. So in my denominator, I just have 2 times 3, which is the square root of 15 over 6. Okay, that is it. Now, this went kind of fast. If you are still confused, I recommend that you watch these problems again. Maybe just watch them the second time and not take notes. Or if you need to clean up your notes, do that. And then you're going to continue on with the rest of today's assignment.